Hello everyone and welcome to Network Playroom. This is the 13th video in the Christmas calendar series, and today we're going to pick up where we left off yesterday and demonstrate the spanning tree topics on the command line. So we were talking about the spanning tree cost and port priority and how they can be used to influence the spanning tree topology calculation. So to summarize, after the root switch is elected, the interface that has the lowest cost path to the root switch becomes the root port. And if there are equal cost paths, the interface with the lowest port ID will be forwarding and the others will be blocking. So let's look at the diagram. I'm using INE rack rentals again, and here we have 3 switches connected with 3 links each. So let's make switch 1 the root switch in a moment by changing the switch priority value. But before I do that, let's think about what's going to happen after I issue the command. So switch 1 here will be the root switch, and then port FA0/13 on switch 3 will be the root port, and similarly port FA0/10 on switch 2 will be the root port, and the others will be blocking. And then we're going to make switch 2 side be the designated on this section, and we'll see that later on. But first, let's start with switch 1. So let's actually use a neat macro command to accomplish the task of making switch 1 the root switch. So the command is spanning tree VLAN root primary, and when you enter this command, the software checks the switch priority of the root switch, and the switch sets its own priority to 24,576 if this value will cause the switch to become the root switch. But if the current root switch has a switch priority lower than 24,576, the switch sets its own priority to 4,096, less than the lowest switch priority. So let's issue that command on switch 1, which I have not here. Okay, this one. So let's just double check. So show spanning tree. Currently this switch is not the root switch, but we don't have to care about that. Here you can see the current bridge ID with a priority of 2,768 and the system ID extension of 1, which is the VLAN ID. So let's change that. So let's do spanning tree VLAN 1 root, and let's just use a question mark for fun. So you can see there's actually 2 commands, primary and secondary. We'll look at the secondary in a moment. But this one is going to be primary. Now, let's see what happened with the show spanning tree output. So as you can see here, this information has changed. So the priority is now 24,576, just as expected. And this line states that this bridge is the root now. So there is that other macro command to set the secondary root switch. And what does that actually even mean, a secondary root switch? Well, just like the placement of the root switch is important, so is the placement of the switch that is going to become the new root switch in case the current root switch fails. For example, if you have a distribution or core layer with 2 switches, you want those to be the primary and secondary root switches, and not some old switch at the edge of the network. So the spanning tree VLAN root secondary command works similar to the spanning tree VLAN root primary command. When you issue this command, the switch priority is modified from the default value to 28,672. So this makes the switch more likely to become the root switch if the primary root switch fails, provided that the other switches in the network have the default priority or higher priority values. So let's see switch 2 here. So let's just check this output as well. So it's currently at its default value. And now let's change it to the secondary root. I like to fully type out the commands just so I can have them in my muscle memory. I know that you can use the tab to complete the command, but it's just my preference when I'm doing labs. Okay, so let's see how this affected the output. So here, you can see the priority is now 28,672. Okay, so switch 1 is now the primary root switch and switch 2 is the secondary root switch. So now that we've done that, so the root port on switch 2 is going to be FA0/10, and then on switch 3, let me look at the diagram briefly. So it's going to be FA0/13. Let's verify that. Well, you could actually do this, show span, but as I mentioned, I like to type out the commands just to have them in my muscle memory. But here you can see that this is the root port, just as expected. Switch 2 is the designated side, as I mentioned here, and this is because it now has a lower bridge ID. So first, let's change the spanning tree costs so that switch 3 will actually prefer the path through switch 2 instead of the directly connected link to switch 1. So to do this, the total path cost must be lower than 19, which is the current lowest cost to reach the root switch, as you can see here under cost. So let's change the cost to 1 on interface FA0/16 on switch 3 and FA0/10 on switch 2. This makes the total path cost 1 plus 1, so that's equal to 2. So what we want to do is change the cost here and change the cost here to make it a total of 2. So let's go on switch 3 here, and then let's go under the interface. Oops, a little typo there. And then we'll do spanning tree VLAN 1, and then cost. Let's see what the range is for this, just out of curiosity. So it's up to, well, that's a big number, but we're gonna change it to 1. And then similarly on switch 2, we're gonna go on the root port interface, FA0/1. Sorry, not /1, it's /10. And then spanning tree VLAN 1 cost 1. So now what this should have done on switch 3, oh, that's switch 1. On switch 3, if we look at the show spanning tree output, it should now prefer the path through FA0/16. It is not forwarding yet. It's actually going through the spanning tree stage. which we haven't discussed yet, and I don't want to get into that now, but let's just wait a moment until the network fully converges. So switch 2 will still have the same root port, only the cost will have changed. So, oh, can I scroll up? Oh, I can't scroll up for some reason, but if you've seen, it was 19 before and now it's changed to 1. All right, let's go back to switch 3. Let's see what's happening over here. Okay, so this is showing the local cost, which we've just configured. So what we want to do now is revert the changes and go back to the original state. So let me do that. Let's do no spanning tree VLAN 1, cost 1. So this is gonna change the configuration back to how it was. And the same thing here, because we're gonna look at the port priority next. Okay, so let's make sure that the configuration has changed now. So as you can see here, the cost was 1, and now if we do show spanning tree, it's back to 19. Show spanning tree to verify here as well. So all the costs are back to 19. And the interface, the directly connected interfaces are the root ports. Well, this never changed. This was the root port the entire time. It's just that we changed the cost. But here, FA0/13 is the root port again. It's now in the listening state. It should have converged by now. Yeah, it's forwarding. So we can move on. So there are 3 links between each switch. And what if we want to change the root port from FA0/13 on switch 3 to, let me see what ports we had there. So we want to change it from FA0/13 to FA0/15. So how can we do that? So to do that, we must change the port priority. And remember, the trick here is to configure it on the upstream device because the port ID is read from the received PPDU. So if we change it locally, then nothing happens. And let's actually do that. So let's change the port priority locally on FA0/13. So interface FA0/13, and then we change this port priority and configure it to 64, for example. So now if we do show spanning tree again, oh, and of course I applied this on the wrong interface. I meant to do it on the other one, which we want to make the new root port. Yeah, that command didn't make much sense. So let's do that again. So we want to do it on the FA0/15 interface. This is what I wanted to do. So now let's look at the spanning tree output again. So as you can see here, we've changed the priority on FA0/15, but nothing's happened. This is still blocking, and FA0/13 is the root port. Confusing, right? So, you're looking at the information and seeing that these interfaces have the same cost, but that this interface has a lower port ID, yet it's not the root port. So watch out for that in exams, because this is an easy mistake to do. I've done it myself many times probably. Now, let me actually change the port priority to the highest value, so it would be seemingly the least likely to become the root port. So let's change it now to, let's go with 240. So now, if we look at the spanning tree output again, it would appear as this port would never become the root port because it has the highest port priority out of any of the interfaces here. But watch what happens when we go to the upstream switch, in this case the root switch, and change the port priority there. So switch 1 is sleeping, we haven't used it in a while. So let's just verify this again, show spanning tree. Okay, so let me just make sure the interface IDs match. Okay, so we need to go on FA0/15. So let's do interface FA0/15 and change the port priority to 32, for example. Spanning tree VLAN 1 port priority 32. So it looks like nothing happened, right? Show spanning tree. A little typo again. Well, I mean, you can see the new configured value here. But if we jump back to switch 3 here, show spanning tree. Watch what happened here. So this one with the highest local port priority is now the root port. So again, it looks so confusing because you're looking at the cost and you're looking at the priority values, and you would think that, oh, this shouldn't be the root port, but somehow it is. So what you actually need to be looking at is this output, show spanning tree interface FA0/15 detail. Now here is where you can see the actual port priority, or the port ID from the received PPDU that is used to determine the root port in this case. So this one is matching what we've configured on the root switch right here. But yeah, I hope that this clarified the concept between the spanning tree cost and the spanning tree port priority for you guys. So I hope you found this informative, although we had to jump around a little bit. But thank you again for watching, and I'll see you in the next video.